Hey everybody, it's Mr. Brooks. I'm gonna go over this warm up right here, or we did it as a warm up or a worksheet. And there's a couple different concepts about functions on it, and so I'm gonna try to work through it and tell you my thoughts, and you can do this your way. But if you hear the way I think about it, that might help guide you a little bit. So the first one says, make a table and graph the function for the given domain, then give the range of the function. So remember that this is called f of x, or it's pronounced f of x. That's your function right here. X is the domain, so this is your input. You're gonna input that into the function. And f of x is another way of saying y. And this is the output, or the range is the output. So when it says range, we're gonna really put this in right here, okay? All right, so the way you think about this is you write the function 3 input minus 5, and you just put the x into where the x was. And then that would be 3 times -1 is -3 minus 5 is -8. And then the next one would be 3 times 0 minus 5, which is 0 minus 5. And just getting stuff. So that'd be minus 5, and then you repeat 3 times 1 minus 5, and that's minus 2, and then 3 times 2 minus 5. That's 6 minus 5 is 1, 3 times 3 minus 5, that's 9 minus 5 is 4. Okay? So a function can be expressed as this equation, it can be expressed as a xy table, it can be expressed as a graph, because of course an xy table is points on a graph, and an equation, if this is y equals mx plus b, we know this is linear. So -1, remember you go x first, this is x, this is y. So x and y. Let's see, -1, -1, 2, 3, 4, 5, 6, 7, 8, 0, -5, 1, 2, 3, 4, 5, 1, -2, 2, 1, 3, 4, 2, 3, 4. And a good check for this is if it's a straight line, like it should form a pattern. Really, any equation should form some kind of pattern. If you get just a bunch of lines going up and down, or you get 2 in a row and then one all of a sudden jumps, then we either miscounted or we did a math thing wrong. And so when you graph this, just connect the dots and then put arrows. Make sure you put arrows, because really for this function, the domain is all real numbers. You can put any number in there you want, and so it goes on forever. And the range in this case, I would say, is going to be from -infinity to +infinity. Remember, this is the y, so it goes down forever, or it goes down forever, or starts down here forever, then it goes up forever. If, I guess you can make a case like, okay, if this is the domain, then the range could be -8, -5, -2, 1, 4. I guess you could say that this is the range for this domain, but realistically, we know it's a line. We know it's going forever. So, all right, write a rule for the function. Let's see. For the input of 15, you go 7, 20. So it looks like you -8, -8, -8. So the rule would be the function of x is the input minus 8. Let's see, 1 to 5, 3 to 15, 4 to 20. So this is the function is 3 times the input. Times 3. 1 times 3 is 5. 3 times 3 is... Oh, no, not 3. Not 3. Times 5. I'm thinking about my rule. Sorry, 5 times 5 is 25, okay? All right, let's see what else. All right, use the vertical line test to determine whether or not each graph below represents a function. So I take my pencil and move it across, or you can just make a vertical line anywhere. well, everywhere. And since it hits twice, it fails, so it is not a function. So this is not a function. Right here, anywhere you draw a vertical line, it passes, so it is a function. And the reason, I'm gonna keep my definition here. Function. The reason is it passes the vertical line test or fails the vertical line test. Tell whether the table or diagram represents a function. I'm going to look at the input, 50, 60, 70, 80, 90. All these are different. So because they're all different, it doesn't matter. If they repeated, then I'd have to make sure that it follows the rule. But yes, each unique input has an output. However you want to word it. Right here, the 5 goes to 0, but here the 7 goes to 3 and to 6. You can't have that. You can't go two places. So no, the 7 gives two outputs. You can put this in your own words, however you want. Okay, I'm gonna move this up a little bit here. Let's try this. All right, I love this question. This is how we use graphs. The graph below shows a short trip that Bob took to visit his grandmother. He took a trip totaling 8 hours. Hours is the input, x, it's marked there, and distance is the output. So he traveled some speed, and then he sped up, traveled a different speed, and then he stayed at his grandma's house, and then he traveled one speed all the way back home. So this is home. This is grandma's house. His grandma lives 120 miles away. That's a long time. Or it's a long distance. Between what two times is Bob's car not moving? Well, this is like constant right here, or there's no movement. So between 3 and 4 hours. Between what two times is Bob traveling to Granny's house? He's traveling to Granny's house, starting here at 0 all the way to 3. So 0 to 3 hours. Between what two times is he traveling the fastest? This is where you look at the slope. So which of these slopes is the fastest? And if you want, you can actually do the math. You might be able to look at this and tell which one is the steepest. But in this case, he travels 60 miles over 2 hours. So there's 60 over 2 is the first interval. And then here he travels 60 miles over 1 hour. So 60 over 1 is right here. And then over this one, he travels 120 miles over 1, 2, 3, 4, 120 over 4. And so which one of these is the biggest? It'd be right here. And this between 2 and 3 hours. This is the fastest. You can kind of see that by the steepness of the line. Evaluate the function. This is a good word, evaluate. If you see the word evaluate, you're definitely plugging something in. This function for f of -5 and f of 1. So for -5, you do -5 plus 2. I'm taking this number and I'm plugging it in this x. Remember, this is a negative. So negative times a negative is a positive. So this is 5 plus 2, and that's 7. And then f of 1, that's -1 plus 2. That's -1 plus 2 is 1. There you go. Find the range of the function if its domain is -3. Okay, so the domain is x. So we're going to find the range. So this is the same thing. -4 times -3 minus 1. And then -4 times 12 minus 1. This is positive 12 minus 1 is 11. This is -48 minus 1 is -49. Okay, so it gives you the domain. This is the domain. This is the range, or the output, or the answer. This one is going to be the opposite. Find the domain of the function. this function if the range is this. So in this case, I'm gonna put negative 23 in the range, and then I'm gonna solve, okay? So plus 3, negative 20 equals 4x, and x is negative 5 when you divide. I'll do one more. There's 3 of them here, so you should be able to do all 3, but the next one would be like 13 equals 4x minus 3. And it's the same thing, plus 3 divided by 4, so 16 equals 4x. So 4 times what number is 16? X equals 4. Okay, find the value of x in the function p of x so that p of x equals negative 3. This is another way of saying this. So find the value of x. So we're going to do negative 3 equals 9x minus 2, and then solve for x. Plus 2, let's see, minus 1 equals 9x. Divided by 9, x is equal to negative 1 divided by 9 is just negative 1 over 9. Perfect. If you want to put this as a decimal, you can. I prefer to leave it as a fraction, but you know, whatever. Which of the following statement is true? The domain is negative 2, negative 1, 0, 1, 2. Well, this is negative 4. 1, 2, 3, 4. This is negative 4, negative 2. So the domain is negative 4. So it's got to have negative 4. So A is not true. The domain is negative 4, negative 2, 0, 2, 4. This is true. The range is all real numbers. If it was connected by a line, it would be all real numbers, but it's not connected by a line, so it's definitely not that one. The range is y is less than 2. That would be like saying it's like all the way under here, so it's not that. Okay. Which of the following best describes the graph? This is a relationship between time and temp. And it looks like as we go through time, the temperature drops. So the longer we are out, or whatever is out, the temperature drops. As time increases, the temperature increases. As time increases, the temperature decreases. That's not it. As time decreases, temperature increases. So no. As time increases, temperature decreases. That's it right there. As time increases, the temperature drops. The temperature does not depend on time. We can see a relationship. Okay, so there's that. And hopefully all this makes sense. If you have any questions, send them my way.